Hi there, welcome back. This is the start of another tube radio restoration project, and this one is local, i.e. it was in Madeira, but it doesn't suffer from the usual woodworm problem because it's actually mostly bakelite. And I like it. This has got two sections. This part in the middle actually does seem to be wood, and then you've got bakelite around it. And the usual brass and all that stuff. So I like the contrast. It should be quite interesting. The one drawback is that this thing only has AM. It's actually just shortwave. You've got shortwave 1, 2, 3, and 4. Actually, this is strange. They call it, it's not shortwave, it's actually AM. This is channels. This is medium wave. I thought it was shortwave 4. Anyway, so we've got the pickup, medium wave, and then I presume 3 shortwave bands. Now this thing's got an on-off switch over here and volume. There's the tone control, treble and bass. Okay, that's fine. And I presume here you've got, yeah, this is all one knob for tuning. Now you see this, this is definitely wood and it's sort of coppery. Pretty interesting stuff. Magic eye. Quite a bit of damage on the cloth there. I have to see what I do about that. But I actually like this set. It looks good. And I guess I should have mentioned it earlier. This is a Wega set, which it looks pretty similar to the normal, I say normal tube radios, but I haven't been able to find a schematic for this because this is an export model with only the AM bands. But I think it's pretty similar to the ones they have on the net, and it shouldn't be too hard to extrapolate from one of the schematics to this one. Here's the full model. It's the Wega Herold K. And K, I presume, has got something to do with the Kurz shortwave. And if we get rid of the back cover, here it is. Nothing too dramatic. Obviously, somebody changed the cord. Looks a little bit iffy. Anyway, what do we have here? We've got the output tube, and it looks like an EL84. Which would be nice because I've got quite a lot of those lying around. This one I don't know, can't read it, but all in good time. The voltage selector allows 220, which is great. It actually allows 240, which is even better. 2 fuses on there. Filter caps. The black thing at the back there is one of those AG type selenium rectifiers. Then you've got the power transformer on the back there with some pretty rough looking caps. No, it's not a cap, that's a tube. Okay, fair enough. IF transformer 1 and 2, or 2 and 1. What are these guys? I'm hoping they're not, you know, series heaters. I see some pretty rough wiring over there to the dial lamp. The wire is chipping away. So this thing has seen quite a bit of bad weather. Tuning condenser. I think that's all strung properly. That's not a problem. Yeah. And we've got the magic eye up here. And this one's actually got, it's a pretty good speaker over there. But it's got the output transformer on top here, which you usually find on the bottom. So this one is slightly more difficult to work with because I do like to, you know, desolder all that. But this one I'm going to have to work with the speaker sort of attached, as it were. We'll figure something out. Shouldn't be too difficult. I see wires going into the speaker. Oh no, it's just excess wires. I was wondering what they were doing in there. I think I may be able to remove the output transformer and disconnect the speaker wires and do the usual thing where I put it onto that stand of mine just to work with it. So enough of the insides. I'm going to take it out of the cabinet and see what we've got. The condition of the cabinet is pretty good. There are no breaks on the Bakelite. It obviously needs a hell of a lot of cleaning and polishing, but I don't see any chips or cracks, which is what worries me most with Bakelite sets. It looks in pretty good condition other than the dirt. And there's quite a bit of that over here. Sort of signs of rust, but nothing too dramatic. I'm not sure we'll be able to get that out, but actually I know we have to, but I'm not sure just how easy it's going to be. Anyway, time to get started. Let me get this out. Well, we've got it out. It's looking a little rough. Quite a lot of grime on there. Some of it looks like rust. But nothing we haven't faced before. There isn't really that much on the top end here. Inside here we've just got some dirt. And this cleans up quite easily because it is Bakelite. You remove that wooden front panel. And I need to do something about the grill cloth. That shouldn't be a problem at all. And from the front, we've got the one knob that was, one push button that was off there. The magic eye, I removed it off its stand at the top there, so that came out and I just rested here. The output transformer, unscrewed from the speaker. That has to be carefully connected to the stand as I restore it. As I said there, the AEG selenium rectifier, the capacitors. I want to put this on the stand and turn it over so we can inspect it a little better. That's next. Well, I was wrong about the output tube. It's not an EL84, it's an EL41. And it's the one with a little bip over there that actually ties in. Can't remember what these are called. Anyway, EL41 output tube, EF41 preamp, ECH42 mixer oscillator, and what is this guy? Can't see it. It'll be like an EF89 type of thing, but we'll see. Now we can see a bit more of the beautiful, beautiful dirt, antique dirt, as well as some spiders. Great stuff. Better get gloves on. Some of those capacitors look a bit rough. Let me turn this over and see from the underside. So what do we have here? Some more paper caps. They've got to go. There's another one underneath there. First thing to do here is going to be to clean this up. See what we've got. We've got an electrolytic over here. It's probably the, where are we? The output. Yeah, that's the cathode bypass. Those resistors normally hold up, but they'll all have to be checked. This one's going to have to go. Another electrolytic at the back there. There we have a couple more caps and a couple more caps, and there really isn't that much else in here. These are the various coils for the tuning or front end and oscillator of the bands. There's the coils and capacitors for trimming. One set will be the front end and one set will be the oscillator. I'm not sure which way around. Is this working? This knob was broken off or disconnected. They seem to be latching okay. I have no idea if this thing's working. I'm not going to switch it on. before I check the power supply. And that's what I'll be doing next, the usual, check the power transformer, check the output transformer. I've shown how I do this in a method which I call safe. It's all relative. I'll link above the power transformer one. Links to a video where I've just focused on the power transformer test offline, and followed by that you can look at the output transformer test, which is also a separate video. And that actually saves me having to go through those tests right here. But I'll get back to you with the results, and we'll carry on from there. Well, it's report back time. This project just took a rather interesting turn. I have to confess that when I started this, I thought it was just going to be a pretty run-of-the-mill restoration of an AM radio. There's no FM, just medium wave and short wave. And I've done quite a few of those, and they seem to be, well, pretty, I won't say boring, because they're not, but pretty similar. Well, this one took a turn, a rather unexpected turn, when I did the test on the transformers. The power transformer seemed fine, but then I saw this. And my blood froze, because that looks like some pretty bad burn damage. And when I tested the output transformer, that was confirmed. It's not completely shorted, but it's certainly messed up. And the result was, when I put a tone into it, like I do in the video where I test output transformers, I got very, very little out at the speaker. So my guess is a whole bunch of those secondary windings are welded together. And so what I decided to do was to change the output transformer. But to do that, and to be able to test it, I had to do quite a bit more. What I actually had to do to prepare for the test of the alternative transformer, which goes up here, is I had to get this thing ready to test audio. In other words, I had to forget about this output transformer, and I had to really check everything as if I was going through the normal procedure with a good output transformer, if that makes any sense. So this is basically what I got down to. I started doing all the checking like I usually do, using the Adobe Acrobat, like I described in a video, and which quite a few people have asked me about. I'm going to go through the circuit very quickly and tell you what I found. So we have the mains coming in here. There's a dual switch, which is operated by the volume control. It goes through two inductors, a 1 amp fuse, and then there's the two filter caps, real dangerous ones over here. They were really bad shape, so I replaced them with safety caps. That feeds the one side of the mains. The other side is fed by the voltage selector, which at the moment is at 220. I'm going to put it at 240 just to make it safer, because the output voltage will probably be a little too high on that. On the output of that, we've got the 6.3 volt winding for the heaters and also for a lamp. I don't see a connection to ground over here, which is a bit strange. I'll see if it's somewhere else, but it's not here. And then we've got the secondary through a 0.5 amp fuse. That is that AG selenium rectifier, which I'll need to change later. And then we've got the filter caps, which I'm not going to change now. I'll need to change later, but that's the first filter cap. Then the B plus is over here. That's B plus. That's going to go up here into the transformer. Now, it goes into the primary of the transformer, comes out of the primary. The other side of the primary goes to the anode of the output tube, which is the EL41. So far, everything's normal. This cap over here is just to filter out noise and high frequencies so you don't get oscillation. That B plus goes through that winding. Part of the output transformer winding acts as an inductive filter and also a bit of humbucking. and it comes through that resistor to the second output capacitor. Everything is normal so far, right? If we go up here now, focus on this tube, this output tube. It's a pentode, so it's got a screen voltage. All the resistors tested fine. All the capacitors were swapped out, as you can see by the red indication. You've got a grid stopper here, grid leak resistor. That's the cathode bypass cap, one of the electrolytics that was swapped out as well. The signal then feeds into the output tube at this point through that cap. This line here is a tone control, and it makes sense. If you look at it, you've got a capacitor, so it's allowing high frequencies to go through. It goes to a 500K pot wired as a variable resistor. So if you imagine this pot is on maximum, it means that all the highs go down to ground, or a lot of them, so that you get very little treble and you get more bass, or at least it sounds like you've got more bass. If you make this high, then that effect of that capacitor is reduced, so very few highs get leaked to ground and you get more treble. It's pretty simple. Over here you've got the signal coming out of this triode. Now this tube, this one is the ABC80. The one we've got is the EF41, is it? Yeah. And I'm only focusing on the triode part. Now the EF41 is a pentode, if I'm not mistaken, but it's wired just to act as an amplification stage. And what we have here is a signal comes into the grid, gets amplified, goes through to out of the anode into the next stage. So I'm focusing on everything that leads up to that triode, that grid of that amplification stage. And we've got this here. It comes from the volume pot over here. The volume pot doesn't have grounded. It goes through a 150 ohm resistor because there's a feedback path, which is that resistor through that capacitor. In this case, this resistor is not there in my circuit. It's slightly different to this one. That goes up there, up there, up there, and it goes to the output of the speaker. And the one side of the speaker is connected to ground. So basically you're getting feedback over here which messes with the ground of this volume pot and acts as negative feedback. Now, what do we have here? This signal comes into the pot from here. There's no 100K resistor over here. There's that capacitor. And we are at this point. And this point is where you'd expect audio to come in. And if you go up a bit further, this is a shielded wire, you get to the switch. And if you look at this side of the switch, if you come down here, you're into your phono input. And that's exactly what I wanted to do, is to be able to test the amplifier, all the audio side, from the phono input. Everything else before that, I'm not interested in at the moment. And this has all been checked, all been swapped out. As you can see, a lot of capacitors, all the capacitors. Haven't done those yet, but will do. And this is what I wanted to do to set up the unit to be able to test or to put in a different output transformer. And I got lucky. I got very lucky. Here's why. I found a transformer from a radio that also uses a EL41 output tube, and I have I've done what you're not supposed to do. And I've got to add a warning here. Do not do this at home, folks. If you're doing this, it's at your own risk. This is very, very dangerous. Very dangerous. What I've done is I've basically cut out the old transformer. Okay. And I made some notes. When I removed that guy, I basically had to go through the schematic on the chassis that had this one. It's a parts radio. And what I have is this. I have got B plus coming in here. B plus coming in here. Ground coming in here. I've got the two speaker wires going off there. I then have the B plus, which comes in here. It's supposed to go through a part of the winding here, but there's no such winding on this one. There's only a resistor over here, and it goes there, and then that's the one that comes back to go through that resistor. So at the moment we've got two resistors. I may have to change that one, probably drop it, if the voltage, the B plus, B2 plus is too low, but I'll leave it there for now. That's a 1.5K. The other thing we've got coming in here is this goes to the anode. So your B plus comes in, goes through the primary, comes out of here, and goes to the anode of the power tube. This is a connection to the speaker out. That comes back, and that's your feedback, which then comes through there and goes all the way down through that feedback network and also to the speaker, out the external speaker connector. And I think that's about all. So what we have here is a bit of a cocktail of crocodile clips. And it's set up very, very precariously just to check that it works. And what I've done is I've connected the speaker to the dummy load thingy over there with the oscilloscope. We can check the signal. And I've done a test already, and I'm going to show you what the result is. Just a note, I have not replaced the selenium rectifier, which I'm going to do. I've not replaced the filter caps, the main filter caps, which I'm going to do. Especially now as we don't have that inductance in the B plus line. We need very good capacitors to compensate for that and just to help filter a bit more. Other than that, the capacitors that I swapped out, you can see there, with the exception of one, that one there. I've used those yellow ones, axials. There are still some paper caps in there that come from the radio circuitry, but I've left that in for now. Everything else seems to be pretty good. It's not too difficult to get into this radio. It's actually got quite a bit of space, but I haven't gone into that section yet, so I'll just leave that for now. So priority number one here is to make sure the audio amp works, make sure that transformer works, and carry on from there. So let me feed a signal into the phono, which is basically those two wires or two connectors over there. That side is ground. That side is the phono signal. I've got a 1 kilohertz signal. I'm going to give it 50 millivolts RMS. That should do. Switch it on. I've just connected the meter, Big Brother, to read B+. And I've got the dim bulb limiter with maximum restriction, so just one bulb, the 40 watt bulb is on, it's on limit. Switch it on. The radio is off because I have to turn it on the volume control switch. What I'll do now is switch it on and move away. You should not do this, all right? You should definitely not do this. We've got it on. The lamp went on and then dimmed again. I've just got to tell you the other tubes, the only tubes I have in here are the preamp and power amp tube. So it's drawing 80 milliamps. I've got the dummy load on dummy rather than speaker on, so I can see that on the scope without hearing the noise. You can see that bulb is starting to glow somewhat as the power tube starts drawing some current. And let's see what we get on the scope. Okay, we've got something. However, it's very low because I've only got 50 millivolts. I've got the volume on max now. I want to see what that comes to. starting to clip there or distort. It's clean till about 1.55 volts RMS. But it's a pretty clean sine wave. And if I mess with the tone control, which is the outer dial here, you'll see that change as well. So our audio amp is working. I've still got maximum restriction on there, and I'm not going to give it less restriction because I'm worried about the rest of the circuit here. Remember, the tubes are out, but there's still quite a lot of caps that need rechanging and so on, and I don't know what condition they're in, and I don't want to blow out right now. So I'm going to use that transformer in place of that guy, and we should be good to go. And of course, I've got to change the filter caps or put some capacitors on the underside there. I still haven't decided how to do that. I'll be changing the selenium rectifier for a normal silicon bridge rectifier. I've got the filter caps here actually. They're actually Nishikon 350 volts at 47 microfarads. 2 of those. At the moment, the one rectifier that I've got is this guy over here, which seems a little bit too small for the job. However, this is a 1000 volt 2 amp. But I don't know, part of me just doesn't trust it. I think I'll just buy one of those normal ones and use that. I'm chicken. I've only got 205 volts in the B+. It's supposed to be 260, but as I said, this thing's on maximum restriction. And the next time you see me, I'll probably have painted more of the schematic and got rid of the caps that I don't need. Just another note here. You see that round thing over there? That's a metal sheet. It's basically rolled into a tube. And that carries in it the caps that are feeding audio to the pot, as well as the cap that's feeding audio from the pot, from the wiper, down here. And that's basically just to shield it from noise. As you can see, there's a nice ground solder wire over there. These resistors are actually in pretty good shape. They've held their value very, very well, including that big guy. It's a 4 watt. The pots are working beautifully. I've cleaned them. I've done some cleaning on the inside as well as some on the chassis. As I do anything, I try to clean the area that I'm working on. There's still a hell of a lot to clean. So I'm going to carry on and then get back to you.